Hello, welcome to another episode where I shall be looking at the proposed memorandum for the Physical Sciences Paper 1. This paper is from the Eastern Cape, okay, for grade 11, June examination 2025. Okay, so this paper has a total of 10 questions, and it was 100 marks for 2 hours. So we just eliminated the instructions just as a formality. So let's see, with the first question, we have the multiple choice question 1. 1.1, which one of the following quantities are all vectors? So one thing we know about vectors is that 1, they must have magnitude, and then 2, they must have direction. So for A, mass does not have direction. For B, electric field, distance doesn't have direction. C, it has direction and magnitude, direction and magnitude, direction and magnitude. So C would be the best option. For D, speed and mass, they all don't have direction. Okay, then 1.2, what is the name of the perpendicular force that a surface exerts on an object in contact with the surface? So that is known as the normal force. Okay, so B is the correct answer there. And then 1.3, the tendency of an object to remain at rest or continue in its uniform motion in a straight line is known as inertia. That's Newton's first law of motion. And then 1.4, the mass and radius of a planet is doubled. Okay, now the mass and the radius of planet A is double the mass and the radius of planet B. Then the mass of a person on planet A is m. What will be the mass of the same person on planet B? So whenever a person moves from one planet to another, the weight might change because of the gravitational forces being different. But then the mass, the contents of the person will still remain the same. So A is the best answer for 1.4. And then 1.5, in the vector diagram below, what is the resultant of the net vector? So what we can see, remember when you're looking for net vector diagram or anything to do with vectors, you must always look at the head and tail. Okay, so this is the tail, this is the head. So this is correct, meaning that F1 must become the resultant. So F2 first and then F that. So F1 becomes the resultant. And then 1.6, if a mag is placed on a table, the reaction force due to the weight of the mag, according to Newton's third law, is the force of. If a mag is placed on a table, the reaction force due to the weight. So if we have weight that is acting downwards, there has to be a counter reaction force, which is the normal force. So that normal force is going to be the table on the mag, okay, which is B. Then 1.7, if we have two charged objects, okay, and they are repelling each other with a force of F, when they are separated by a distance R, the distance between the charges will now be reduced to a third of R. What will be the new force? So meaning that originally we had K, Q1, Q2 over R squared, but now we are decreasing the distance, meaning that's K, Q1, Q2 over 1 over 3R squared. So 1 over 3 squared is going to be 1 over 9, meaning that our answer should be 9 K Q1 Q2 over R squared, which is 9 times of the F, meaning that if the distance decreases, the force should be getting greater and bigger. Then 1.8, we're saying in the diagram below, the north pole of a bar magnet approaches the end A of a solenoid, okay? Which one of the following statements about the polarity A and the direction of the induced current shows the deflection of the galvanometer needle? So one thing we know, when you talk about induced current, induced polarity, we must put that into consideration. That number one, that if the north pole is being moved closer to A, the south pole will be created by point A. Okay. Now, if this is the south, automatically this end will be the north. And we know that the current will be flowing from the north towards the south. Why am I putting this arrow here? Okay. We're saying the current will be flowing from the north towards the south. meaning that we said from the north to the south. So the galvanometer will be moving in the anti-clockwise direction, which means the left. So which option is that? We have the north and left. No, we're focusing on the south, sorry. So this is south and right, south and left. So I'll go with option D. All right, then next, 1.9. The potential difference across the battery in the circuit is given as 10. Okay, we have 10V here. And then the internal resistance can be ignored. 2 voltmeters are connected in the circuit below. So when the switch is open, okay, what will be the voltmeter readings? Now, for as long as the switch is open, there will be no reading in V2. Okay, but the fact that V1 is connected across the battery, we shall have a 10V there. So 10 for V1 and then 0 for V2, which is option B. Then 1.10, what is the unit charge of electrical power? So we know that power is given as the work done divided by the time, the rate at which work is done. And if this is true, we know that work is given in joules, okay? And then time is given in seconds, which means joules per second would be the best unit for electrical power. All right, then question number 2. We have forces, 3 of them, F1, F2, F3 are applied to a crate which is 15 kilograms, okay, as shown in the diagram. Then they want us to define the term resultant vector. So we know that resultant vector is a single vector that would represent the effect of all the individual vectors. So one single vector that has the same effect as each of those vectors combined. And then 2.2, they want us to calculate the resultant of the 3 forces. So whenever we are calculating the resultant, remember we need to resolve these forces, okay, into the horizontal as well as the vertical, and then before we can get the overall resultant. So when I look at the forces in question, number 1, we need to change, okay, what's going on here? Okay, we're saying we need to create a triangle here. This is a 90. Let's also create another one here, and then we try to resolve them. So meaning that the vertical component here is going to be 500, the sine of this angle here, which is like a 60, okay, because 30 and 60 is 90. So I'll use this approach, okay? And then down here, we're going to have the 500 cos of 60. And then here we're going to have 600 negative, but that's going to be the sine of 50. And then somewhere there, we're going to have the 600 cos of 50. All right, so then I just need to get the horizontal. So with the horizontal, I'm seeing this, that, and the 450. Okay. So meaning that I'll have the 500 cos of 60 plus the 600 cos of 50. I can say plus a negative 450 because it is in the opposite direction. So when I simplify this and I punch that into my calculator, I'm getting 185.67 newtons. Okay, then I go to the vertical. So vertical, I only have this and then this one. So the 500 first. Okay, so it's 500 sine of 60 plus a negative 600 sine of 50. I punch that in the calculator, I'm getting a negative 26.61 newtons. Okay, so I have my horizontal and I have my vertical component. So this is the vertical. Then if I try to represent this horizontal in that direction, the vertical just in that direction. So for me to get my resultant, I need to find the Pythagoras, okay? So we're saying vertical force resultant will be the square root of 26,61 squared plus 185,67 squared. Okay, the resultant of that I'm getting is 187,57 newtons. Okay, that's if I round it off. Okay, but now since we're focusing on force being a vector quantity, we must also find the direction. Okay, theta will be the arctan of the 26,61 over the 185,67. This gives me 8,16 degrees. So that's what the question basically wanted. Then 2.3. Can we explain why the three forces will not form a closed vector diagram? Now, for us to have a closed vector diagram, the resultant force must be a zero, which is not the case for this one. Okay, so the explanation is going to be that the resultant force is not a zero. The resultant force is not a zero. All right, so that is question number 2. Then we move on to question number 3. They're telling us that a constant force F pulls a 20 kilogram block at a constant speed of a rough horizontal surface XY as shown in the diagram. Coefficient of kinetic friction between the block and the surface is 0,2, okay. 0.1, can we give a reason why the coefficient of kinetic friction has no unit? Now, the reason as to why it doesn't have a unit is because it is a ratio. Okay, so it's a ratio of the velocities between the surface and then the object. That's why we have no unit. Okay, all the units will cancel out. Then 3.2, they want us to draw a free body diagram that is acting on the block. So when you look at this block, we're seeing that we have this applied force. There's going to be the frictional force, F mu. We're going to have the weight acting downwards, and then we're going to have the Fn. So let's just represent this with just a dot. Okay, so we can have this as our F. Then we're going to have this as our weight. We're going to have this as our F mu. And then we're going to have this as our Fn, normal force. So 4 forces for 4 marks. Pretty good. All right, so we always use the dot and not the box. And then 3.3, can we state Newton's first law of motion in words? So we saw this in the multiple choice. So we say that an object will remain at rest or uniform motion in a straight line unless acted upon by an external force, or some people say a resultant force or a non-zero force. So an object must continue in its state of rest or uniform motion unless there is an external force that is acting on that object. Then 3.4, they want us to get the magnitude of F, force F. So when we look at this F, there are 2 components for F. We have the horizontal component, but we also have the vertical component. So this is going to be F sine of 35. We're going to have F cos of 35. So which one do you think we can use? Okay. Which one can we use? So let's use the horizontal one. I think to make life a bit easier. So I'll say that F cos of 35 should give us the frictional force, which frictional force is given as mu multiplied by the normal reaction. Does that make sense? Yeah. So it's going to be F cos of 35 is equal to 0,2 multiplied by the mass, which is 20 times the 9,8. Okay. So if that is true, I'll make F the subject and say 0,2 times 20 times 9,8 divided by the cos of 35. And then this F gives me an answer of a 47,85. Then they want me to get the normal force. Now, normal force is having 2 components, okay? For normal force, we think that this weight is equivalent to this and this component here. So it's going to be the weight plus the F sine of 35. Meaning that our weight is going to be 20 times 9,8 plus the F, which is 47,85, the sine of 35. So this gives me an answer of 66,65 newtons. Then 3.4.3, they want us to get the frictional force. So the frictional force is also going to change drastically because of the change within the normal force. So meaning that our frictional force is going to be mu multiplied by the normal force. I'll say Fn. So 0,2 multiplied by the 66,65, this becomes a 13,33 newtons. All right, then 3.5, the same constant force F is now applied to the block, but then we are reducing the inclination to something less than 35, to just something like a 15. So they're asking us, how would the frictional force compare? So the frictional force is going to be a little bit higher. Okay, and why is that so? Because the normal force is going to increase. The fact that the inclination decreased, this component here becomes smaller, so the normal force will also increase. Okay, so question number 4. In the diagram below, we have an 8 kilogram block connected to a 4 kilogram block by means of a light string. There's a constant force of 55, and then apply to the block so that the block can accelerate. Okay, so the kinetic friction between the 4 kg is 4 newtons, and then that between the 8 kg is 8 newtons. Can we state Newton's second law? So with Newton's second law, we need to know that when a force, okay, acts on an object, let me try to write it this side. We're saying that when a force acts on an object, okay, an object will accelerate, or the object will accelerate in the direction of the force, and the acceleration is directly proportional to the force, and inversely proportional to the mass. Okay, so that is how the second law could be stated. Then draw a free body diagram of the 4 kg. So this 4 kg is having this as the tension. We know that we're going to have the FG parallel. We're going to have the weight. And then we're going to have the normal force. But we also have the frictional force there. So what we can do, we can just eliminate the FG parallel and focus on just the frictional force. So that is tension. And this is normal force. This is weight. We can say this is frictional force. 4 forces for 4 marks. Then calculate the tension that is connecting the 2 blocks. Okay, so for me to get the tension, I need to look at one block at a time. Okay, so if I focus on the 4 kg block, I know that F net must give us MA, meaning that if I look at the direction to be upwards, it's going to be the tension minus the FG parallel minus the frictional force should give us the MA. Okay, so our tension is what we're looking for. Our FG parallel is mg, the sine of beta. So that is 4 times 9,8. The sine of 30 minus the frictional force they gave us is 4, should give us 4A. Okay, so from this, I'll have my first approach, which is going to be, what is 4 times 9,8? That's going to be 2. That's going to be 19,6 minus 4. Okay, so let's see, 19,6 minus 4, which gives me 15,6. meaning that T is going to be 4A minus plus 15,6. I'll call that equation number 1. Then I look at the 8 kg block. That's going to be still the same formula. F net is equal to MA. So 55 minus the tension minus the frictional force, which is 8, should give us 8A. So what is 55 minus 8? Gives me 47. So 47 minus 8A should give us the tension. So that is equation number 2. Let me equate the two. So 4A plus 15,6 should give me 47 minus 8A. Okay. Let me move the 15,6 there. Let me move the 8 that side. So it's going to be 12A is equal to, what is 47 plus 15,6? Getting 62,6. Did we do anything wrong? Let me just go up here by the forces, the first ones, and confirm. 4 times 9,8 sine of 30. Okay. We are plussing 4. There we go. There we go. We're getting a 23,6, not a 15,6. Okay, this is otherwise, yeah. Because that acceleration is going to be too big. So we're saying it's a 4A plus a 23,6. This is a 23,6. So let's subtract that. And why are we having 60? Why are we plussing? We're supposed to minus, because it was 47 minus 23,6, which gives me 23,4. Okay. And then I can now divide both sides by 12. So over 12 and then over 12. And then our A becomes 2, it's 1,95. Sorry, it's 1,95 meters per second. Okay, so that is what I'm ending up with if I use this approach. But then the question is asking for the tension, meaning that our tension is going to be 4 multiplied by 1,95 plus the 23,6. Okay, 4 times 1,95 plus the 23,6, which becomes 31,4 newtons. 31,4 newtons. Okay, so that is what I'm getting. Please just verify with the calculations, and if there's anything that we probably left out, please just help us, okay? But that's how I would have gone about it. Then 4.4, the angle of inclination is now decreased to a 10. Okay, how will it change how will the change affect the coefficient of kinetic friction? So the coefficient is just going to remain the same. Remember, because the coefficient just works with the surfaces, okay? The surface of the block and then the surface of the incline, okay? So it's saying it remains the same because the coefficient is not affected by the inclination. Coefficient can never be affected by the inclination. All right, question number 5. A crane at a building site lifts a container filled with concrete and their combined total mass is 780. Container is lifted upward at a constant speed. So this word is even in capital letters, no? By means of a light and extensible cable. Ignore the effects of friction. Can we draw a free body diagram? Forces, container is being lifted for 2 marks. So those are 2 forces. So we have the weight and then we have the tension. Then calculate the tension within the cable. So tension is equal to weight from our F net is equal to MA, meaning that our tension is going to be the weight, which is 780 multiplied by 9,8. Okay, so 780 times 9,8 gives me 7644. 7644 newtons. Okay, then the train changes the tension cable to one of 7,800. Okay, so how will this change influence the acceleration of the container? How will the change affect the acceleration of the container? So as long as the tension cable increases, okay, chances are high the acceleration must also increase. Why? Because we know that F net, remember we said is equal to MA. The tension, it will be directly proportional to the acceleration according to our explanations. Then 5.3.2, calculate the acceleration of the container. So from our F net being equal to MA, okay, we know that tension minus the weight should give us the MA. Now, what was that tension now? It is 7,800. The weight initially we got in the first place, which was 7,644, should give us the mass, which is 760. It's 760 or 780? It's 780 times A. Then we subtract that side. So 7.8 minus 7,644. I'm getting 156. Then I'll divide this by 780 so that I get my acceleration value. And that gives me something like 0.2 meters per second squared. So that is question number 5. And then question number 6. Question number 6, we have the Earth, we have a satellite. And then they're telling us a satellite of this mass is orbiting the Earth at a distance of 1.2 kilometers from the Earth's surface. So they're asking us, how does the force which the Earth exerts on the satellite compare to the force that the satellite exerts on the Earth? So the answer will be equal to, remember the forces have to be the same but just opposite, okay? Can we state the relevant law that you apply to answer the question? That is Newton's law. Newton's law of universal gravitation. Newton's law of universal gravitation. Okay, and then they ask us to state that law. Can we state that law? Is that Newton's law of universal gravitation? Does it make sense? How does the force exert? No, it's Newton's third law, not this is Newton's third law, not universal. Newton's third law. Then they ask us to state Newton's law of universal gravitation. So we know that a body in space exerts a force towards another body, okay, and then the force is directly proportional to the product of the magnitude of the masses and inversely proportional to the square of the distance between them. Okay, for two bodies in space, okay, the force experienced will be directly proportional to the product of the masses and inversely proportional to the square of the distance between them. That's how you would state Newton's law of universal gravitation. And then calculate the force that the Earth exerts on the satellite to keep it within the orbit. So what we have here is just the distance from the surface, and we said the distance must always be from the center. So we need the radius of the Earth here, okay? We need the mass of the Earth as well. So the mass of the Earth is 5.98 times 10 to the 24. The radius is basically 6.38 times 10 to the 6. So we can get all this information from the formula page or the information page. Then we can go ahead and say F is G M1 M2 over R squared. So G is a constant, which is a 6 times 6, 7 times 10 to the negative 11. Okay. We're multiplying it with the first mass, which is 1,000. The second mass, which is 5,98 times 10 to the 24. And then we are dividing this. We say the radius, we have to plus. So we're going to have 6,38 times 10 to the 6 plus 1,2 times 10 to the 6. Everything needs to be squared. So when you punch this into the calculator, I'm ending up with 6942,06 newtons. Okay, so that is the force that I would have obtained. Then 6.4. The mass and the radius of planet A are this much and that much, respectively. Can we calculate the acceleration due to gravity? Now, the formula that we use for the acceleration due to gravity is just G is equal to Gm over R squared. So 6,67 times 10 to the negative 11, the mass is 7,35 times 10 to the 22. The distance of separation is in kilometers. We need to change this to meters. It's going to be 1737 times 10 to the 3. This needs to be squared. Okay, so when we punch this into the calculator, what will be the gravity? 6,67 said 10 to the negative 11, multiplying by 7,35 times 10 to the 22 over 1737 times 10 to the 3, but squared. So this gives me 1,624. This is meters per second squared. Okay, so that is to do with the acceleration due to gravity on planet A, so small. All right, then question number 7, we have 3 identical spheres, A, B, and C, that are brought together. We have these charges, and C is neutral. Then the spheres will be separated after contact. Okay, calculate the net charge on each of the spheres. So after the separation, all the spheres must have the same charge. So when a sphere is neutral, which means it has no charge at all. So you're going to have the charge on A plus the charge on B plus the charge on C divided by 3. So it's a positive 5 plus a negative 8 plus 0 divided by 3, which gives us a negative 1, but nanocoulomb. So that is the net charge. And then calculate the number of electrons in excess or deficit on sphere C. So sphere C had 0. Okay. And then it attained negative 1 electrons, nanocoulomb charge, sorry, not electrons. So for us to get the number of electrons, we normally use this formula. N is equal to Q over E. So the charge attained was a negative 1 times 10 to the negative 9 over the electron charge is 1,6 times 10 to the negative 19. Okay, when we punch this into the calculator, I'm ending up with 6,25 times 10 to the 9 electrons. So that's how much was obtained after the separation. Then they're telling us that the 3 are put apart as seen. We need to draw a vector diagram showing the electrostatic forces. Now, since all of them are having the same charges, okay, there's going to be repulsion. Okay, so from B to C, it's going to be repulsion. And then from A to B, it's also going to be repulsion. So my vector force is going to be B. I'll have this to be my force of A on B being repelled, and then this being the force of B on C. It's also a repulsion. And then calculate the net electrostatic force, So for the net, I need to first of all calculate this and also calculate that, and then I'll subtract the two since they're in opposite direction. So the force of B on C is going to be K Q1 Q2 over R squared. Okay, 9 times 10 to the 9. The Q1 we say it's 1 times 10 to the negative 9. The Q2 is the same, 1 times 10 to the negative 9 divided by r squared, which is 15 centimeters. We change that to meters. It's going to be 0.15, but squared. And I punch that, I'm getting 4 times 10 to the negative 7. Okay. That is for BC. Then for AB, I'll do the same thing, Q1, Q2 over r squared. So it's just going to be the same, but the distance of separation is going to be kind of different. 1 times 10 to the negative 9, 1 times 10 to the negative 9, and then the distance will be 0.2 squared. So this gives me 2.25 times 10 to the negative 7. Now, the fact that the two forces are in opposite directions, I'll get the bigger force and then subtract that. So it's going to be 4 times 10 to the negative 7 minus 2.25 times 10 to the negative 7, which gives me a resultant of 1.75 times 10 to the negative 7. All right, then question number 8, two charges Q1, Q2, magnitude of that much with unknown signs respectively are placed in a vacuum as the diagram shown. P is a point, a distance r to the right of Q1, 0.2 of Q2. The net electric field at P is equal to 0. So the net electric field here is a 0. Are the signs on the two charges similar or opposite? The answer needs to be, is it similar or opposite? No, it can't be opposite, because if it's opposite, then we're not going to have a 0 net. So it's going to be similar. Why is it similar? Because there's going to be some bit of repulsion, okay? So repulsion of the charges, creates a net 0 zone. Okay, there will be a zone of where the force is 0. Okay, then draw the electric field pattern of a positive charge. As a positive charge is just field lines that are moving out, okay? What we care about is just the arrows, which direction. So something like that. That's all they need. And then 8.3, can we define what an electric field at a point in words is? So this is the force, okay, per unit charge that would be experienced. Is the force per unit charge that will be experienced. That would be experienced by a test charge or a positive test charge at that point. And then calculate the distance r. Since the net is a 0, then we just have to look for that. So we know that electric field is given as E being kq over r squared. So 9 times 10 to the 9. The charge of Q1 is 4 micro. So that is 4 times 10 to the negative 6 divided by the distance of separation, which is r, okay? And so if the net is 0, which means the A of Q1 must also be the same as the E of Q2. So I'm just going to equate and say this is 9 times multiplied by the 3 micro, so it's a 3 times 10 to the negative 6 over the distance, which is a 0.2 squared. Okay, so that is what we are having. And then I'll do the magic of cross multiplying. So 9 times 10 to the 9 times 4 times 10 to the negative 6. We multiply it by 0.2 squared over, that is squared, sorry. 9 times 10 to the 9 times 3 times 10 to the negative 6 should give us r squared. Let me just put this under square root just to get one value of r, okay? From there, we can cancel this and that, cancel this and that, and then I'm left with 4 over 3 times 0.2 squared under the square root. So when I punch that the calculator, I'll end up with 0.23 meters. Okay, so that is what I'm ending up with. Then question number 9, a coil with 340 turns. Okay, so we know that the N is 340. The area is 0.06. and then the B is 0.4 Tesla. And then we know that the change in time is just going to be 0.3 seconds. Then they want us to state Faraday's law of electromagnetic induction. So this law tells us that the magnitude of the induced EMF, okay, or the induced EMF in a conducting circuit or in a conductor is proportional, is directly proportional to the rate of change in magnetic flux linkage within the circuit. So it talks about the induced EMF as well as the change in the magnetic flux linkage. The 9.2 mentioned two ways in which the magnitude of the induced EMF can be increased. Number one, you need to increase the number of turns. Okay, increase the number of turns. Okay, these ones, a coil with 340 turns, so we need to increase them. And then two, increase the magnetic strength, or the magnetic field should be increased. Okay, so I think that's the two basic ones we can always think of. Okay, we can also talk about the angle and so on and so forth. The 9.3, they want us to calculate the magnetic flux linkage. Okay, so 9.3.1, for us to get the magnetic flux linkage is going to be the B multiplied by the A and then the cos of theta. Okay, but then this we have to multiply it by the N, the number of turns. Okay, so it's going to be a 340 multiplied by the field strength, which is 0.4 Tesla. The area is 0.06, and then it's going to be the cos of 0. Okay, since they told us that it is parallel. Then when we punch this into the calculator, I'm getting something like 8.16 Weber. Okay, so that's what the question wanted. And the 9.3.2. What does the question want? They want us to get the magnitude of the induced EMF. Now, our induced EMF is going to be negative since we've already calculated the linkage. Okay, this is the magnetic flux linkage. So we're just going to get to this change in flux, which is going to be the 0, minus, minus, and so on, which means it's going to be just 8.16 divided by the 3. Was it 3 or 0.3? It was 0.3. Yeah, we're going to divide it by the 0.3. So this gives me 27.2 volts. Okay, so a negative and negative will give us a positive. So that's how we would have gone about with that question. All right, question number 10, which is the last one. They're telling us that a group of learners use the circuit diagram below to investigate the relationship between the potential difference across the ends of a conductor as well as the current that is passing through the conductor. Okay, the following results were obtained. Then they want us to write down the independent. What were the learners investigating? The relationship between the potential difference across the ends of a conductor and the current that is passing through it. Now, in this case, remember for dependent, independent is something that is not affected. Okay, so in this case, we're going to have our potential difference as our independent variable. Okay, it's potential difference PD. They name the law that the learners are investigating. This is what we call Ohm's law. And then use the attached to draw the graph. So when you look at the graph, it should be something like this. The current is here, and then the voltage is that side. So if this is, let's say 1, 2, 3, 4, okay, and then we can have a 0.5, we can have a 1, a 1.5, and then a 2. So 1 is going with 0.5, this is 0.9 is going with a 2, and then we're seeing 3 is going to be 1.5, and then 2 is going with a 4. and then you just connect this, should give you somewhat a straight line. Okay, and then 10.4, write down the conclusion for the investigation. So the conclusion is going to tell us that the potential difference, okay, potential difference across a conductor is directly proportional to the current at a constant temperature. Okay, so that is what the conclusion could have been by stating Ohm's law. Then 10.5, the battery in the circuit diagram below has an EMF of 14V with a negligible internal resistance, which S is closed. Calculate the total resistance. Now with the total resistance, we're seeing that there is a block for the parallel combination, okay? So when I plus these two, I'm gonna get a 12. So still they are still in parallel, meaning that for me to get the parallel one, it's going to be the product over the sum, okay, RP1. So it is 6 times 12 over 6 plus 12. So it's a 72 over 18, which gives me a 4 ohm, okay? So this entire thing just reduces to a 4 ohm. Now, if it's a 4 ohm plus the 3 ohm, okay, so it's going to be 4 ohm plus the 3 ohm, which gives me 7 ohms. So that is the total resistance. Then they want us to get the reading on the ammeter. So they're asking for the current. We know that V is equal to IR. This is 10.5.2. Our voltage is 14. We saw the resistance is 7, and then I. Let's divide by 7, meaning that the total current is just 2 amps. Then if it's 2 amps there, meaning that it's the 2 amps that are traveling throughout, but here they're going to split up. They want us to get the energy dissipated by the 8 ohm in 2 minutes. What needs to be done? Number one, we need to get the current that is passing through here. For us to get the current, we need to find the voltage, because the voltage here is going to be different from the voltage this side. So let me start by getting the voltage across the 3 ohm, meaning that it's I and R. So it's a 2 by 3, which gives me 6V. Okay. Is that true? Because we say the current is that, and then the resistance is 3, so which is 6V. And then the remaining voltage is going to be 14 minus 6, which gives me 8 volts. So this parallel combination is going to have 8 volts within it. Okay, so if it is 8 volts, what is the current through the 6 ohm? So I through the 6 ohm is going to be the voltage over the resistance, which is 8 divided by 6, which gives me a 4 over, it's going to be a 4 over 3. So if this top part is taking 4 over 3, meaning that the remaining current, which is going to be the current through the 8 ohm, is going to be 2 minus 4 over 3, which is 6 minus 4, which is a 2 over 3. Okay, 2 over 3 amps. Now we have the current that we need. What they want is the energy. Okay, so for us to get the energy, we can use the power rating. Okay, we know that power is given as I. Should we use IV or I squared R? Let's use I squared R. So we're going to have a 2 over 3 squared multiplied by the resistance, which is 8. The 2 minutes need to be changed into seconds, so times 2 times 60. Let's see what we end up with in this case. So that's going to be 4 over 9. Okay, times 8 times 2 times 60, which gives me 1280 over 3, or 426, 0.67. Okay, since it's energy, it's supposed to be joules. It's supposed to be joules. Okay, then 10.6, the last one, potential difference across will be 220. And then the current is just 16 amps. And then the time is 30 minutes. So 30 times 60, which is like 1.8. Okay. So let's start by determining the power. Okay, we know that power is given as IV. So it's a 220 multiplied by 16, which gives us 3520. And then this is we need the energy as well. We need the energy as well. Okay, so this is the power, meaning that we're gonna divide this by 1,000, which is gonna be 3.52 kilowatt hours. Okay, but then we know that 30 minutes is basically half of an hour. So we're going to multiply this by 0.5. This 30 is supposed to divide, not multiply. What's wrong with me? It's supposed to be 30 over 60, which is 0.5. Okay, then that will give me something like 1.76 kilowatt hour units. Then multiply this by 2.56. So when I multiply, I'm gonna end up with just a $4.51. Okay, so that is what was expected of us, grade 11s. For those that have not yet written, we wish you all the best, and just use this as just a revision guide. All right, bye-bye for now.